Hi everyone, today we are going to discuss about the origin and evolution of the Earth, which is the chapter number 2 title of the Physical Geography class 11. Okay, so let us discuss. So first of all, we are going to understand the origin of the Earth. So when we talk about the origin of the Earth, so we have two sets of theories, which is first set of theories known as the early theory of the Earth, early theory for the origin of the Earth, and the second one is the modern theories. Okay, so we will discuss one by one. So first, let us discuss the early theory. Okay, so there was a German philosopher named Immanuel Kant. Okay, who first of all gave the one of the earliest and the popular arguments. Okay, regarding the origin of the Earth, which is known as the nebular hypothesis, which was later on revised by Laplace in 1796. Okay, so what is nebular hypothesis? So this hypothesis considered that the planets were formed out of a cloud of material. Okay, so the planets were formed out of a cloud of material which was associated with the youthful sun, which was slowly rotating. Okay, let me repeat again. So, what was the nebula hypothesis? So, nebula hypothesis consider that the planets were formed out of a cloud of material associated with a youngful sun, which was slowly rotating. Okay, then there were many other names also who were giving their hypothesis or theory. Okay, so Otto Schmidt in Russia and Weizsäcker in Germany somewhat revised the nebula hypothesis in later on. Okay, so they considered the sun was surrounded by solar nebula containing mostly the hydrogen and helium, along with what may be termed as dust. The friction and collision of particles led to the formation of a disk-shaped cloud, and the planets were formed out of through the process of accretion. Okay, so that is the thing. But the scientists in later period took up the problems of origin of universe rather than the just that of just the Earth or the planets. Okay, now it is important that we must understand some of the theories which is from the modern times. Okay, so first is about the origin of the universe. So the most popular argument regarding the origin of the universe is the Big Bang theory. It is also called as the expanding universe hypothesis. It was propounded by the Edwin Hubble in 1920, who said that the universe is expanding. Now, what is this mean? What is the meaning of this? Universe is expanding. So basically, the distance between two galaxies are expanding. Okay, so this means that the distance between two galaxies are increasing. Okay, so that is the thing. So the distance between the galaxies also found to be increasing, and thereby the universe is considered to be expanding. Okay, now there were several stages in the development of the universe according to Big Bang theory. So first, it said that in the beginning all matters forming the universe existed in one place in the form of a tiny ball singular atom with an unimaginably small volume, infinite temperature, and infinite density. Okay, second, at the Big Bang, the tiny ball exploded violently. This led to a huge expansion. It is now generally accepted that the event of Big Bang took place 13.7 billion years before the present. The expansion continues even to the present day. As it grew, some energy was converted into matter. Okay. Thereafter, the expansion has slowed down. Within first 3 minutes of Big Bang event, the first atom began to form, and within 3 lakh years from the Big Bang, temperature drops to 4,500 Kelvin and gave rise to the atomic matter. The universe became transparent. The expansion of universe means increase in space between the galaxies. An alternative to this was Hoyle's concept of steady state. Okay, so after that, the Hoyles comes and who gave the alternative theory to the Big Bang, which is known as the steady state. Now, what is this? So it considered that universe to be roughly the same at any point of time. However, this is not much important. Okay, so let us see the star formation. So the distribution of matter and the energy was not even in the early universe. These initial density differences gave rise to the differences in gravitational forces. Okay, so they are saying that if there is a density difference, then there will be difference in the gravitational forces as well, and that is why it caused the matter to get drawn together, and these form the base for the development of galaxy. Now, what is a galaxy? So galaxy contains a large number of stars. Galaxies spread over the vast distances that are measured in thousands of light years. Galaxy stars are formed by accumulation of hydrogen gas in the form of a very large cloud called nebula. Now, eventually, growing nebula develops localized clumps of gas. These clumps continue to grow into even denser gaseous bodies, giving rise to formation of stars. The formation of stars is believed to have taken place some 5 to 6 billion years ago. A light year is a measure of distance and not of time. Light travels at a speed of 3 lakh kilometer per second. Now, how the formation of the planets happen? So these are the development stages of the development of planets. So the stars are localized lumps of gas within the nebula. The gravitational force within the lumps leads to the formation of a core to the gas cloud and a huge rotating disk of gas, and thus develops around the gas core. In the next stage, the gas cloud starts getting condensed, and the matter around the core develops into a small rounded objects. These small rounded objects, by the process of cohesion, develop into what is called planetesimals. Large bodies start forming by collision, and gravitational attraction causes the material to stick together. Uh, Planetesimals are a large number of smaller bodies. In the final stage, these large number of small planetesimals accrete to form a fewer large bodies in the form of planets. Okay, now let us talk about the evolution of the Earth. So, planet Earth was initially barren, rocky, and hot object with a thin atmosphere of hydrogen and helium. Now, the Earth has a layered structure. The material that exists is not uniform. The atmospheric matter has least density from the surface to the deeper depths. The Earth's interior has different zones, and each of these contains material with different characteristics. Now, evolution of the lithosphere. Okay, so the just a minute. Yes. So the Earth was mostly in volatile state during its primordial stage.